Good day. Today, I will be discussing about the physics of ionizing radiation. Most people fear ionizing radiation. Certainly, it can cause death if we are exposed to too much, and the most recent symbol for it makes it clear to stay away from it. However, ionizing radiation, like many things, isn't bad unless a living organism is exposed to too much of it. So what is ionizing radiation? Ionizing radiation is any type of radiation that has so much energy that it can free electrons from atoms. This means has a short wavelength in the electromagnetic spectrum, the UV, X-ray, and gamma-ray radiation. Any material that undergoes spontaneous decay is said to be radioactive. The process is stochastic and will emit either alpha particles, which are the least penetrating, can be stopped by a piece of paper, beta particles, which are quite penetrating and can be stopped by a sheet of aluminum, or gamma particles, which are very penetrating or stopped by a slab of concrete. Since ionizing radiation is not visible to the naked eye, to find out whether or not the ionizing radiation is a health threat, we can measure the rate of incident particles using a Geiger-Müller tube and counter. Ionizing radiation is any type of particle or electromagnetic wave that carries enough energy to ionize or remove electrons from an atom. So as you can see here in the first picture, the alpha decay. So it has a nucleus that ejects an alpha particle which is identical to an ionized helium nucleus. The second picture is the beta minus decay happens when a neutron within an atom's nucleus transforms into a proton, and an electron and an antineutrino are ejected out of the nucleus of an atom. For a beta plus decay, a proton transforms to a neutron and positron, similar to an electron but with a positive charge, and a neutrino are ejected out of the nucleus. There are two types of electromagnetic waves that can ionize atoms. So first, the gamma radiation. Second is the X-rays. So X-rays and gamma rays, and sometimes, yes, they have the same energy. So here in gamma radiation, produced by interactions within the nucleus. X-rays are produced outside of the nucleus by electrons. So there are officially two types of ionizing radiation that are energetic particles emitted during an interaction within the nucleus. The alpha particle is composed of two protons and two neutrons, or a helium nucleus. The beta particle is either a positron or an electron. Neutrons emitted during some nuclear decay processes are often included as ionizing particles, but they do not actually ionize an atom directly. So neutrons interact with another nucleus, which may result in a secondary process involving ionizing radiation. So why is ionizing radiation dangerous? When atoms in living cells become ionized, one of three things usually happen. The cell dies, the cell repairs itself, or the cell mutates incorrectly and can become cancerous. Not all cells are affected by ionizing radiation in the same way. The cells that reproduce the most and are the least specialized are the most likely to be affected by ionizing radiation. For example, those in a forming fetus. Radiation is effective as a cancer treatment because it can kill the cancer cells. However, it can also kill or damage nearby cells. When radiation is used to treat cancer, it must be pinpointed very carefully. New technologies, similar to imaging techniques used in CT scans, called tomotherapy, it helps pinpoint radiation treatment. Tomotherapy allows radiologists to apply the ionizing energy directly to the perimeter and within the tumor while avoiding the healthy cells surrounding it. Some aggressive cancers, such as liver cancer, are being treated with a new internal method or radiation therapy, sent through an artery that feeds the liver, microscopic encapsulated spheres containing radioactive isotopes get directly embedded into the liver and destroy cancer cells. Even though this type of treatment is new, internal radiation treatment is not new. Internal radiation treatment is called brachytherapy. The National Cancer Institute has a plethora of information on radiation treatments of cancer and other cancer treatments. When living organisms are exposed to the low amounts of background radiation, there is very little effect overall on the organism. When radiation exposure of larger amounts occurs, even if it is for a short time, damage, radiation poisoning, and even death can occur. So here in the picture, it is the design of a nuclear power plant with pressurized water reactor, or the PWR. So the experts have determined that exposure to doses of 10 to 50 rem may increase your chances of cancer and will have observable short-term effects on blood cells. Doses between 50 to 100 rem over a short time have observable effects, and over a long time will increase your chances of cancer. Above 100 rem, if you receive the dose in a short amount of time, you might experience nausea and would require medical attention. Above 500 rem, in a short amount of time, may cause death within a few days.